Hey guys, Mr. Ferguson here on Wrestling with Math, and today we're going to talk about a geometric sequence and finding the nth term of a geometric sequence. My geometric sequence is in the top right hand corner. A sub n equals a sub 1, parentheses here, r raised to the, so this one does have an exponent here, n minus 1. A of 1 is my first term, r is my common ratio here, the number that's being multiplied each time, and n is my term number. So I'm going to do two examples here. The first one here, find the 12th term of the geometric sequence below, 4, -8, 16. And then here I'm going to do one that goes, the numbers get bigger, okay, in a sense, they do go positive, negative. And then one where the numbers get smaller here, so our ratio is going to be slightly different here. We did talk about geometric sequences being very similar to exponential functions, so they do relate in that way. So the 12th term of the geometric sequence, well, if I have my formula here, well, I have a of 1, okay, which is 4. I have the term number, which is 12, but I need to know the common ratio. So like we did in the previous video, we're going to pick any term we want here, and I'm going to divide the previous term by it. So here, let me go ahead and just take the second term, which is -8, and I'm going to divide the previous term here. So I'm going to divide 4. -8 divided by 4 is -2, which means that if this were holding true here, the common ratio is -2, so R equals. So go ahead and fill these into my formula here. I'm looking for A of 12, the 12th term here. A of 1 is 4. I open up my set of parentheses. My R is my ratio of -2. And I'm going to raise this to 12 minus 1. Okay, if you want to go ahead and write 11, that's fine. Again, the good thing about this is I can plug this all into my calculator, which I'm going to do here. Okay, so I have 4, open up my parentheses, -2, and I'm going to go ahead and raise it to the 12 minus 1 power here, and I get -8,192. So that is my 12th term. Again, a way to check myself, well, it's negative here. Am I sure it's negative or positive? You could look at your sequence here. Well, the first term is positive, the second term is negative, the third term is positive, which means that the odd numbers are going to be positive where the even numbers are going to be negative here. So the 12th term is negative. You could also, if you really wanted to, multiply 16 by -2 by -2 by -2 to get to the 12th term. But again, this number could be a lot higher. It could be the 20th, it could be the 40th, it could be the 150th term. So we want to make sure we have a formula that we're able to use here. So A of 12 equals -8,192. And just one other example here, find the 9th term of the geometric sequence. So we have 24, 8, 8 over 3. Okay, we start getting into fractions here, which is a little iffy here. This will probably be a decimal here. On Delta Math, it says round to the nearest thousandth, so I'm just going to show you guys what to do here. Again, I need to find out what my common ratio is, so off to the side, I'm going to pick any term I want. I'm going to go ahead and pick the second term, and I'm going to divide it by the previous term here, 24. Okay, I'm going to go ahead and divide these. Yes, I get a decimal, but I want to turn it into a fraction, so my common ratio is 1 over 3. And then I'm going to go ahead and plug these into your formula here. So I'm looking for the 9th term. A of 1 is 24. My common ratio is 1/3, which means this is getting smaller. And I'm looking for the 9th term, so I'm going to plug in 9 minus 1. Okay, so go to your calculator here. 24 parentheses 1 divided by 3. Remember, fractions can be put in just as a division problem here. And I'm going to raise it to the 8th power here, 9 minus 1. So the decimal that I get here is 0.003657. Okay, I want to round to the nearest thousandth. So tenths, hundredths, thousandths. Okay, so this is my value that I'm rounding. I do check the next one over to determine whether it stays the same or it does get bumped up here. So since 6 will cause this to bump up, my final answer is 0.004. Again, we're getting into really small numbers. These are exponential functions here, so they can be really big and really small. So my 9th term of this geometric sequence, 0.004. So hopefully this helped you guys out, and thanks a lot, guys.